we're given a cosine of alpha is 3/4. So our goal here is to draw the right triangle and then to find all 5 of the additional trigonometric ratios based on that triangle. So as we get going on this, let's just kind of draw an arbitrary right triangle. So I'm going to put the right angle down in the bottom left. I'm going to go ahead and label alpha to be here, and it is important to indicate which corner, which angle is going to represent your alpha. In our case, it's alpha. It could be theta, could be a different letter. All right, from here, let's go ahead and use SohCahToa to help label our sides. So cosine of alpha is 3/4. Well, cosine is adjacent over hypotenuse. So as we label this, I'm going to say my adjacent is 3. And the hypotenuse goes as 4. And let's go ahead and label this. This is going to be the hypotenuse on this side, the adjacent at the bottom, and then the opposite side will be over here. Now to get sine and tangent, sine is going to be opposite over hypotenuse, so we need the opposite side. Tangent is going to be opposite over adjacent, so again, we need that opposite side length. So let's do a little bit of work to see if we can find that opposite side length. For the time being, I'm just going to label it as maybe A. You could use B. You could just use like an X along the way. What we're trying to do though is we want to use the Pythagorean theorem. All right, Pythagorean theorem, usually a pretty easy one to memorize. That's a squared plus b squared equals c squared. It's important that c is going to be the hypotenuse length though. So in our case, as we fill in, since I labeled this as A, I'm going to leave it as A squared plus 3 squared equals 4 squared. So A squared plus 9 equals 16. To isolate the A squared, I'm going to subtract 9 from both sides. So 16 minus 9 is going to leave us with 7. And then to get A all by itself, we'll apply a square root to both sides. So A is going to be the square root of 7. Now, I'm not concerned about the plus and minus because of the situation that's represented here, that this is a side length of a triangle. It wouldn't make sense in our case to have a negative side length. So I'm going to use square root of 7 on the opposite side of my triangle. All right, now to set up our trigonometric ratios, let's work on finding sine of alpha. Well, sine is going to be opposite over hypotenuse. So as we labeled it, that's going to be the square root of 7 over the hypotenuse, which is going to be 4. All right, next up, the tangent of alpha is going to be the opposite over adjacent. So opposite in our case is square root of 7. And the adjacent is going to be 3. Now that we have the first 3 trigonometric ratios, cosine, sine, and tangent, we can get the next 3 as long as we understand the reciprocal identities. What we mean by that is, if you know sine, you can get cosecant. There's always a pair of s and a c for these starting ones going hand in hand. What we mean by reciprocal is you take this ratio and you invert it, you flip it upside down. So cosecant of alpha would be 4 over the square root of 7. Secant is going to go hand in hand with cosine because remember they always start with an s and a c get paired up. So because cosine of alpha was 3/4, we can say secant of alpha is 4/3. And then finally, cotangent and tangent go hand in hand. What we're going to do is we're going to invert that, use its reciprocal. We can say 3 over the square root of 7. Now we could do a little bit of work and rationalize these denominators. What we mean by that is getting rid of the square root from the denominator. So I'll just do it on the cosecant one here at the top. What we would want to do is multiply numerator and denominator both by the square root of 7. That would give us 4 multiplied by the square root of 7 over the square root of 49 for our denominator. Well, the square root of 49 works out to be 7. All right, so that would be a nice rationalized solution for the cosecant, this ratio. We could do something very, very similar down here with the cotangent by multiplying numerator and denominator by square root of 7. If we were asked to rationalize this, this will give us 3 square root of 7 over 7 for our final result. Most reduced down, best answer possible. All right, hope this helps out as you need to sketch a triangle and find these trigonometric ratios. Good luck.